My name is Nitesh Kumar. I am a second year B Pharmacy student and I am pursuing my course from Siddhant College of Pharmacy. Today I am going to present a topic on phase rule, which is the part of our one subject called physical pharmaceutics. Then it goes. The first we should know what is phase. The phase is the part whose physical and chemical properties are completely equal and homogeneous. It is separated from one another part of the system by interface. A system containing water and its vapor in a two-phase system, and equilibrium mixture of ice, liquid, water, and vapor in three-phase system. The phase formula is F is equals to C plus P. C plus P. And then we should know about the phase diagram. The phase diagram is also known as equilibrium diagram. So it shows the multi-system states changes with the temperature, pressure, composition, and intensive properties. The simplest phase diagram are pressure and pressure diagram of a single simple substances. Here in this solid, liquid, and gaseous phase is connected to when they join when they intersect each other. This point is called as triple point. Then the axis correspond to the pressure and temperature. The line in the phase diagram represent two-phase system. Then the lines which represent the lines represent the two-phase system, and the space. The space between the lines is known as one-phase system. Is known as one-phase system. Then we should know what the phase system is divided into three parts: one component, two component, and three component phase system. Here we should know about the one component system. Considering one component system composed of a liquid with a particular volume, using the phase formula as I got C is equals to temperature and C is refer as temperature and P is refer as pressure. So here the temperature is 1 and plus the pressure is 2. So 1 minus 1 plus 2 is equals to 2. The maximum number of degree of freedom for one component, and only two independent variables are required to define the system, and that two requires a pressure and temperature. Now here when liquid and vapor is in a phase is called 1 and the pressure is 2 plus 2 is equals to 1, and only one independent variable is required to define the system. Either it should be temperature or pressure. Then for this, in this we need three surfaces: solid, liquid, and vapors. In this phase, the 1 minus 3 plus 2 is equals to 0. But means that three phases is 3, and in further we know that the two phases is 2, and that further is one phase. Then there are no degree of freedom. The ice, water, vapor system. And is completely defined by temperature, and pressure is fixed at a point called as triple point. Here. Then two component system. The system containing more than one component are as discussed, and condensed system. Condensed systems are a system in which the vapor pressure is ignored and only solid and liquid phase is considered. In condensed system, we can ignore the pressure, but we should consider the solid and liquid phases. The system containing liquid obtained are classified as completely immiscible, and partially immiscible. Then for two component system, C is equals to 2, F is equals to C minus P plus 2, where F is equals to 4 minus P. Then P is equals to 1 at least. So F is 3 at most. Then three variables are required. Temperature, pressure, and composition. If the pressure is fixed, then C is equals to 2 and F is equals to C minus P plus 1, where F is equals to 3 minus P, and P is equals to 1 at least. So F is 2 at most, and only our temperature and compositions are required. In this, only temperature and compositions are required. Then two component system containing liquid phases. The phase diagram for two component systems are commonly constructed with temperature and composition as the coordinates. Usually the composition is expressed as the mole fraction or as a percent by weight. Then the two component systems for solid and liquid phases. The two component system consists of solid D and E, both temperature above melting point or both point D. The one phase system will form consisting of liquid solution D D and E, and the point of D and E represent the melting point. It represents the melting point. Then when the temperature falls to point C, when the temperature falls to point C, the pure solid E will form this depressed in a solution D and E. Then the three component system containing liquid phases. Phase diagram are commonly constructed an equilateral triangle with the three peaks that separately stands for pure compositions A, B and C. Thank you.